Look at all this good stuff going on in 6. And so I'm starting off with red pen because we're going to talk about a very important law in math that some of you are going to want to break because your brain's going to tell you to. So we need to look at x plus 1 divided by x. And here's what your brain is going to want to do. Cancel those. 1 plus 1 is 2. So that's my poster with the puppy on it. I call that puppy killing. Every time you do that, a puppy dies. I know, just so you feel guilty about doing it. That's called puppy killing. Can't do that. Well, let's talk about why mathematically. Give me any value of x. 7. So if I replace 7 plus 1 over 7, can I cancel the 7s and say that that's 2? Well, what's 7 plus 1? Is 8 sevenths the same as 2? Doesn't work mathematically. What do you do with this? Nothing. There's no way to simplify x plus 1 over x. You cannot cancel those x's. You cannot simplify. What your brain is going to want to do is cancel the cosecant on the top and the secant on the bottom. That's what your brain is going to tell you to do because it looks like there's one on the top and one on the bottom. But according to this, you cannot cancel half a binomial. I'm going to say that probably 1,000,000 times between now and the end of the year. You cannot cancel half a binomial. When you are adding, you cannot cancel one of the pieces. If you are multiplying pieces, that's a different story, and we'll get to those questions later. But when you are adding, you cannot cancel half of what you're adding. Okay, so when you look at this, your brain's going to want to cancel. No, cannot cancel half a binomial because a puppy will die and it will be all your fault. What do? We go back to our steps. Change to sine and cos. So first, pick a side, left-hand side or right-hand side. Now imagine I didn't cancel all that stuff. Where do you want to start? What do you want to do with cosecant squared? And secant squared, what would you like to change it to? Remember we talked about these guys you can square and they're still true. These guys you cannot unsquare. So we can square these and they're a-okay. So I can say cosecant squared is 1 squared over sine squared. Okay, what would you like to change secant squared to? And then I'm going to draw a really big dividing line just so I'm keeping in mind visually what was on the top, what was on the bottom. On the bottom I have a secant, which I'm going to change to 1 over cos, and a cosecant into 1 over sine. I'm going to do the bottom first because it's easier, and I just want to show you a trick for visual people. When you're multiplying two things, for some visual people, it's handy to put the brackets in because your brain understands that brackets beside each other is multiplication. That also stops you from putting some kind of plus sign in there. If that doesn't mean anything to you, then don't worry about it. How do we multiply fractions? Top times top, bottom times. So I'm going to leave space and come back to the numerators. I'm going to keep that big dividing line, and I'm just doing the bottom first. So 1 times 1. And sine times cos, sine cos. We just slap them together. Now I'm going to go back to the numerator, and again, if visually this is a lot, then just cover the bottom. Don't look at it, it's done. We're just looking at the top. How do I add fractions? Common denominator. What's common between sine squared and cos squared? Ooh, love it. The first fraction, what did I multiply to go from sine squared to sine squared cos squared? Okay, so 1 times cos squared at the top, cos squared. The second fraction, what did I multiply cos squared by to get sine squared cos squared? Sine squared, so 1 times sine squared, sine squared. Okay, so still keeping that big dividing line, still keeping the bottom that I haven't touched yet. What do we do on the top once we have that common denominator piece? Keep the bottom. And just smush the top together. What your brain is going to want to do here is cancel the cos squared with the cos squared and the sine squared with the sine squared. Can we cancel? Why not? Because there's an addition on the top and you cannot cancel half a binomial. Okay, so resist the urge to cancel. What can we do, Andrew Stein back there? Yes?
We can simplify the cos squared theta plus sine squared theta into a line.
Okay, so the top is now 1 over sine squared cos squared. That was so much fun. And the bottom is still what it was.
You said math isn't exciting.
It so is. Whoever said it wasn't. Okay, now what?
Bottom to top.
Okay, so flipping that one, or however you choose to divide in your head. Can I cancel here? Yes. Why can I cancel in this step and I couldn't above? There's no plus sign. When you're multiplying pieces, cancel away. It's when you're plussing, can't touch it. So a sine can go with the squared on the bottom. A cos can go with the squared on the bottom. What's left with all of this? One is on the top, and a sine cos. Change sine and cos, done. Sine squared plus cos squared, done. Simplify all fractions, done. Try to factor.
Not necessary.
Can't, because this is only one term. Okay, next on our list is if you're stuck, go to the other side. Okay, what do you want to do on this side? Okay. And can I cancel? But there's a cos on the top and a cos on the bottom and a sine on the top and a plus. No, that's killing puppies. Cannot cancel here. The only time you can cancel is when you're multiplying. What do we do if we can't cancel? What's the common denominator? And already you should be like, oh, I like this. Look at what's happening. What does the top of the first fraction become? What does the top of the second fraction become? Everybody okay there what I did? Because I skipped a step, so I want to make sure you're okay with me. So how do you go from sine to sine cos? What did you multiply by? So cos times cos, and then sine times sine. And then?
It becomes 1.
And then?
QED.
Oh my God, I love identities so much.
How many words would a question like this be?
4. So there'd be 1 for changing the identities in here, 1 for getting down to the simplifying, 1 for changing here, and 1 to get down to the simplifying. So it'd be typically a 4-mark question. Don't say cat. Drive me crazy. Number 7. Tan squared over a secant theta minus or plus 1. And then a 1 minus cos over cos. How? How does all this happen? You want the long way or the short way? Okay. The long way is change the sine and cos, and that's usually our first step, but the more you do of these, the more you're going to start to see patterns. And the fact we have a tan and a secant probably should jump out at you, and I want you to take a look at the back of your card. What do you see with a tan and a secant? Is there a formula that maybe links them together? Yeah, so instead of changing to sine and cos, which is a fine method, it will get you there in the end, I'm just showing you the short route, is I can take out tan squared and I can put secant squared minus 1. How did I know to do that and not change to sine and cos? Because I've done a bajillion of these. And you start to see patterns with sine and cos. Again, you could change to sine and cos. This is just going to be shorter. Can I cancel? No, can't cancel anything here. So we go to our list. Simplify all fractions. Anything I can do here, simplify? Try to factor. Grab your red pen. Grade 9. We looked at what was called difference of squares. Difference of squares is when there's two terms, there's a negative in the middle, and both the terms are perfect squares. Do you remember those? Oh. Okay, so that was like grade 9. And then we were like, ooh, like let's get really tricky, like grade 10. Right, we did that. Remember that? And then later in grade 10, we were like, ooh, let's put just some variables here. And that freaked everybody out. So follow the pattern.
X plus y, x minus y.
Right, so we're just following a pattern. So what if I gave you sine squared minus 1? Let's just follow the pattern.
Sine plus 1, sine minus 1.
With me there? And what if I gave you something like sine squared minus cos squared? Ooh,
Sine
ooh,
plus
ooh.
cos, sine minus cos. It's really easy, actually.
You with me there? As I wrote that really, really fast. So these are called difference of squares. And you're going to run into a lot of difference of squares with these because we always have squareds minus 1. Okay, so take a look at that. Can we factor it? Yes. So a secant squared minus 1 is going to break down into secant minus 1, secant plus 1, and what I'm going to do for visual people, so if they want to look up for a second, is I'm just going to bracket the bottom because sometimes your brain sees easier what's going to happen there. Why can I cancel here? And before I was like, no touchy. Because I'm multiplying. As long as we're multiplying, we're okay. So what's left? A secant theta minus 1. What do you want to do with that? Well, if you're ever stuck, like peek at the other side and say, well, what do I need? What do I need gone from the left and what do I need on the right? I need secant out and I need cos in. So is there a formula that joins secant and cos?
1 over cos.
How do I subtract fractions? Okay, so cos is going to be the common denominator. How do I go from a cos to a cos? Multiply by 1. How do I go from imaginary 1 to a cos? Multiply by cos. Now we talked about this Friday. Again, your brain is going to tell you to cancel these coses because we have spent 6 years telling you to cancel, cancel, simplify, simplify, reduce, reduce. If you were to simplify this cos over cos, what's going to happen? You're going right back up here. So if you happen to what I call loop back, it just means you shouldn't have canceled it. What do we do now that we have common denominator? Oh, and dance of joy. Oh, this feels so good. So good. Again, is this the only way? No, you could have absolutely changed to sine and cos. You would eventually get down to here. You're just going to use more steps. And there's nothing wrong with that.
Except we waste more.
We do waste some paper and some time.
We already have to waste paper by writing our fractions on more than one.
I know, but you'll thank me. You'll thank me later. Take a look at number 8. What do you see there? Scary, scary things.
I thought Halloween wasn't for another 25 days.
No, apparently all of October is Halloween in math. Again, I picked these examples very deliberately, so they all have something a little bit different with them.
In this case, we've got powers of 4.
The 4s. The 4s are probably a little scary because we don't do a lot with stuff to the 4.
We haven't done anything.
Remember this? Remember this? Remember this? Okay, what if I change these to 4s? It'd be x squared plus y squared and x squared minus y squared. So it's still just a difference of squares. So what can we do on the left-hand side? Exactly the same. Let's factor it out. Cos to the 4 goes to cos squared. Sine to the 4th goes to sine squared. What are the signs always in the middle? One is plus and one is a minus. OMG. Cos squared plus sine squared. And you don't have to write it. I'm just showing you when you look back where it went. So what I'm left with is a cos squared minus a sine squared. That's always how you're going to get rid of an exponent of 4. It's going to always factor down into this, and the 1 binomial will always equal 1. Okay. Change sine and cos. Simplify fractions. Factor. Difference of squares. There's no 2 there. There's no 2 there. Difference of squares, can I factor? Yes, but I don't want to. And how do I know I don't want to is because I need a squared on the other side. And if I factor, I'm going to get rid of the squareds. So you'll know that if I did it, I'm never going to get to the other side. So it's telling you that that's not the right process. Start working on the complicated side. Well, I'm kind of there. So again, we're down to that. Well, what do I need to get gone? What do I need over here that's over here? What do I need to get rid of? I need the cos squared to stay. I need to get rid of the sine squared. Okay. Do we have anything that links sine squared and cos squared? Okay, so I'm going to keep this cos squared that's in the front. I'm going to keep the minus that was there. And I'm going to take out sine squared, and what am I going to put in its place? Why did I do that? Because I know by looking at the other side that I need sine to be gone. And that's the only way to get rid of sine is to change it into 1 minus cos squared. Okay, let's simplify. What do I do with this negative and these brackets? So just kind of distribute. I've got a cos squared still stuck in front. A minus times 1 is minus 1. A minus times a minus is plus cos squared. And these are just like terms. So this is like if you had x squared minus 1 plus x squared. What would you want to do with it? You'd want to put together the like terms. So you would say x squared and x squared is 2x squared minus 1. Same deal over here. If I have 1 cos squared and another cos squared, I have 2 cos squared minus 1. Happy dance. Anytime you see next to the 4, it's going to be something like this. It's going to be a difference of squares to get rid of it. Last one. Left-hand side or right-hand side? Okay. Change sine and cos.
Already changed.
Done. Look for sine squared plus cos squared. Simplify fractions. Factor. So remember to factor, we're looking for squareds or fourths now, anything with an even exponent. Can't. Work on the other side, okay. Right-hand side. Change sine and cos. Done. Factor. Can't. Simplify fractions. What do we do when there's nothing else we can do? This is where we pull out that conjugate binomial that's the last on our list. So this is a last resort. If we can do nothing else, we do conjugate binomial. I'll tell you why in a second. So let's review conjugate binomial, grabbing my red pen. You saw conjugate binomial when you were rationalizing stuff like this. It was whenever you had 2 roots on the bottom. And the problem with rationalizing is we couldn't just times by root 3, and we couldn't just times with root 2, so we grabbed this thing called the conjugate. Anyone remember what the conjugate was? What would we multiply by to rationalize this guy? Root 3 minus root 2, remember? Kind of remember that? So the conjugate binomial of a plus b is a minus b. The conjugate binomial is the same terms opposite side. Okay? Conjugate binomial of a plus b is a minus b. Kind of remember this? Okay. There's only one binomial on the left-hand side, so what I'm going to do is multiply by its conjugate. So I'm going to keep exactly what's on the left, my sine over 1 minus cos. And I'm going to multiply by 1 plus cos. Just making a note, this is called the conjugate binomial. Again, it's a last resort because what's going to happen is it's going to slightly complicate our identity before it makes it easier. So we tend not to do it unless we can't do anything else because it's going to make it a little bit more complicated. The problem is mathematically, I can't just multiply by something like that. The only thing I can multiply by is a value of 1 because anything times 1 is itself. So just like with rationalizing is I couldn't just multiply the bottom, is I multiplied the top and the bottom. I need to do the same thing here. I also need to multiply the top by 1 plus cos theta. And the only reason mathematically I can do this is because my second fraction is equal to 1. Otherwise, I can't just start multiplying something on one side of an identity. The only reason it works is because it's equal to 1. With me so far? The top piece, I'm not actually going to multiply out. I'm just going to smush them together, and I'll tell you why when we get down to the next step. I'm just going to write it as sine, and then times 1 plus cos. The bottom I am going to multiply out, just like over here. I multiplied out to get rid of the radicals. What I want to do here is change the expression. Again, to visual people, sometimes the brackets see better that you're foiling. Sometimes our brain is just used to seeing brackets, so if your brain likes those, put those in. So we're just foiling here. So 1 times 1 is 1. And 1 times cos is cos. And negative cos times 1 is negative cos. And negative cos times positive cos is negative cos squared. Still with me? And we know that these coses are going to cancel because I'm just collecting like terms. So keeping the top at sine theta and then 1 plus cos in brackets. And on the bottom I have 1 minus cos squared. So already when you peek, we got something good going on here because we got our 1 plus cos. Why did I not multiply out the top? Because one of our steps is to factor. So had I chosen to multiply this out, I would have turned right now and factored it. So you might want to make a note when using the conjugate, don't multiply the other piece. So the non-binomial piece, don't multiply. Again, you can. It just means you're going to turn around right now and factor, so there's no point in doing it. Andrew, was that a question I saw there?
Yes.
Yes. Oh, wait, no, don't spoil the fun. You can see lots of light bulbs going on. Lots of people see it. Peeking, what needs to go? Well, I need this cos squared gone on the bottom, and what do I need? A sine. Do I have a formula that links a cos squared and a sine squared? 1 minus sine squared, or in this case, 1 minus cos squared is sine squared. So I'm going to keep the top exactly as it is. Going to take out 1 minus cos squared, put in sine squared. Oh, what do you see? Why can I cancel here? And I've already told you a bunch of times you can't cancel. Because I am multiplying this sine squared. I'm not adding it to anything. And as long as you're multiplying, canceling is fine. So on the top, I've got 1 plus cos squared. And on the bottom, sine squared. There is no way to solve this identity without the conjugate binomial. There's no other way to do it. You're going to recognize conjugate binomial questions because the two sides kind of look the same. The denominators and numerators are kind of switched, and there'll be a sign change. So anytime you're like, ooh, these are kind of the same, but one's flipped a little bit, it's going to be a conjugate binomial question. You'll also know conjugate binomials because when you go through all those other hints, there's nothing else you can do. If you're stuck, it's a conjugate binomial question. Again, we tend not to do this unless we have to because it makes it more complicated for a while until we can get down to this. So we like to keep it as a last resort if we can't do anything else. Questions?